Welcome again to Wickerson Studios. I'm going to continue with the Grasshopper for Rhino series, the ABCs, 1, 2, 3s. And as I get through these, the params, the math, sets, vectors, and into the curves, we've done the primitives, the splines, and now we're into division. I think it is time to slow down a little bit to recognize what you're doing. So I'm going to go into here, pull up my file that I've activated all the nodes in there. You've seen I've gone through the nodes to the first two sections. I kept them in order that, well, out of order. Primitives first, you want to get a hold of. The splines are very tricky to start thinking about what you can do. And definitely the division tools. Even though there's few of them, slow down and take a look at them. So when you go in and you grab something like contour, you're going to start wanting to use this tool. Right-click on the node, go to help, and read this. Take the time to read exactly. And if you're not following this, what it's telling you to do, ABC 1, 2, 3, then you may not know what the node can do, and it will give you some helpful tips. So please go into those things. I'm going to leave this off and take a look at the contours. What I've set up for this in the contours is a sense of interpolating that and seeing the points that are coming out of that. There's no reason for me, I don't think I have to flatten that. Yes, I did. I had to flatten my points, obviously, because they're not in a flip matrix formation. I'll show you that later. Basically, you're going to want to bring in a curve and reparametrize it. And I brought in this curve, which you can see here, and I've also brought in multitude of curves. And those curves can be visualized that way, and this one's brought in this way. And I've actually just built those for the purpose of this demonstration. So if I go into here and just choose the 1 curve, which will be easiest for the demo, you can grab a point external to that. You can move that point around, and that will show you how that influences these points. But I thought it was nice to take that curve, and this is an interesting trick. Take a points on curve, put that in as your point, and start to change that. And basically the difference is you're going to see as you manipulate, you have a little different control on where those points are by points on curve. I think that's pretty cool control as opposed to just taking a point external and not having any control points to it. Of course, you have to make that point go directly to there. So sorry, point has to go here, and then you can see that you don't have that control. It's just split it up. The other thing you can do, which is very interesting, is you can change your direction planes. So if I put back on this point tool here and start to play with that, if I change that to the x-axis, x direction, I get a totally other kind of weird bird happening, like a mirrored imagery, reflective happening between those points. And my size is so far split between here, I'm going to make it smaller so you can see some additional points. But look at how that points on curve is having an effect of where on that reparametrized curve I'm splitting it, and then how I'm actually looking at it from different direction planes. So go to the z-plane and it changes it once again. So XYZ might be interesting, and then you can also change that direction unit to any vector you want to create. The distance is the distance between it, and you can see that we're getting multiple information in this system with a X and a Z plane, but if you use a Y plane, you're going to get a ton of single points that have all been grafted. So very interesting, and these are parameters that are actually saying where along that curve line those points exist all the way down, which is very nice. It's between 0 and 1. The next thing I want to show you is the contour external, or X, which basically allows you to go in and make a point to do the same thing, whereas the plane I've chosen here, I might go back to Y plane, which might allow for something different. There it is. It's coming off the extends from the offsets from the outside, and there's a range of what that can do. It says if you don't use offsets, then you have to use distance, which kind of puts it back into the mode of what the contour was doing up here, at least in my opinion, similar to that. But that said, I always use interpolation to have a view of it. Dash patterns, pretty cool if you think geometrically. Not only can I get control of the gaps, of the pieces that are being dashed in there as geometries, it can actually visualize the gaps, which is pretty interesting. I guess we're looking at the gaps right now, which is what does that mean for geometry or planning? And if you were to do multiple curves on this, that's where it gets interesting to bring in multiple curves. I don't think you have to reparametrize, but now you've got a bunch of geometries you can kind of dash, create, stagger, step, offset with lists. Don't forget, when you go in the curves, you don't have to take it farther in the surfaces and all these other things and intersections and transformations. You can go backwards into the vectors, the sets, and the maths to figure them out. As we continue, we've got a curve here that I'm using all of the curves, and I thought that would be interesting to divide the curve. And there is a kinks tool which allows you, and that's once again, click the help, it'll tell you, you can split the segments at kinks if you boolean that on as true. And I think it comes on false, but it's not necessary in this curve because this curve's so simple it doesn't have any kinks. But you can split that up, take a look at your segments divided by just dividing the curve, whereas it gives you a chance to divide the distance and divide the lengths. And in these, take a look at what happens as I interpolate them. And I was playing around with this first divide that, okay, I interpolate that curve. I get some pretty interesting geometries wrapping away this way. But because we're dealing with lines, you can think of the interpolation going this way and that way, which is why the flip matrix tool is so interesting to bring in and see how you're visualizing it differently. I was playing with the knot style, true or false, making it periodic. And I'll show you how the knot style has a little more of an effect when you're playing with divide distance or divide length. If you end up with a curve here that you've actually made it so it closes, you get these very interesting kind of ribs of a fish or a boat, not really knowing what's going on. You loft them into some strange geometries. But take a look at the knot style as I play through these and how those geometries are transformed. And you can soften them and do things with those. And knots, if you think about it, there's special kind of kink marks. You're going to want to know what a NURBS curve is, where are the control points, what are the weights that are pulling those off to knots, and different weight and different kinks in that structure. And that's why I think curves, you got to slow down, really analyze what you're doing with curves. So break this down. Yes, Ella, I love you. Yes, I'll be there in a minute. And so basically get in here and look at the output parameters and consider what those actually mean, because you're not only, you're gathering data from different things as well. Yeah, I'll be there 1 second. All right, and then we'll go down. We're almost done. I've got a shatter tool, which I use all the time to shatter up, and I think of those as point indexes. So if I grab that shatter tool and just shatter it at a parameter, parameters you want to wrap your head around once reparameterized, that's going to go between 0 and 1. So I can shatter this tool at any point along there. Ella, you're being wicked. Okay, I'll be right there. Go, and I'll be right there. I love you. All right, here we go. Oh, she's upset. And what I did, oh, I jumped down too far. The index number is what I can change. As I go into this tool, I can actually grab the index number. So obviously that's just one. It just goes back and forth from those two. But it's interesting to use a gene pool. Beth, can you grab her for a second? I don't want to redo this video. I can grab a gene pool and set that and edit between 1 and 0. I can randomize that, and now I get a whole section of different segments that if I start to play off the list numbers, where are those actually going as they shatter through and show me different lengths. Great way to grab a bunch of different geometries from a very simple shatter tool. We're almost done. Curve frames are nice. They pop them on, and what I did was oriented some mesh boxes on those so you can actually see where those planes are and how they have an effect. And sometimes with this and perpendicular frames and horizontal frames, they clean up what the curve frames does. I think in dividing, in a sense that you can mess up your normals, or your X and Y can get switched sometimes when you're putting these planes on. I've had that happen. But this is a nice way of analyzing and seeing, okay, am I still in good shape? Maybe a cube isn't the best thing to look at, but a cylinder certainly would help you see that as you orient non-uniform geometry. Don't put a sphere or a cube on there. Put something else. Or if you put a cube on, give the other thing a bigger count in the Y direction so you could actually sense what those look like as a count. I think that worked, unless I put it in too far. That's too hard to see with so little dots. Sorry for this slowdown. I thought the geometry would have... Oh, sorry, it's just splitting it in the same cube. What am I talking about? But you can kind of see like which way the lines go here. It's not the best tool to do it, but that's it. I then take the perpendicular frames, horizontal frames and perpendicular frames, and you can see the difference between those cubes and those cubes. So you get a different orientation when doing those and a different count on each of them. And of course, I've just used those same curves the entire time. I hope that helps. Make a little file. Like I said, I'll pop these on GitHub, and you can play with them, and it gets every node running. And I wish I had this when I had started. And I love my daughter, Ella. I'm glad I have her, too. All right, so that's it. And I'm going to pop this over to a nice, pleasant blue and say we're done. Excuse me. And we're going to go into analysis and utility after this for curves. And then we'll slowly go on the surfaces, and things are going to slow down. There's lots of little tricks. You're going to get stuck on kind of the visuals. But I think if you want to get into the real back-end type stuff that's happening here, you'll chase this so far back into the maths that you're entering back into C+ and Python programming and Visual Script that you're going to then have to know how to program all of what you wanted to do here as basic script within those node systems. So you can go either way in all of this. Very exciting to think about what the future is. I think it's like practicing karate, and the black belt should know the first moves of the white belt again and again until they're doing all the steps and strikes and blocks almost in the same instant. So you can go back and grab any one of these files, like the params that I put up on my GitHub, and run through those nodes again and make sure you're operating not just the things that are familiar to you. Go into these with the right click, go into help, and really analyze all the outputs and inputs, like why you would want gap segments, how will you end up using those. And then you're building some awesome complex scripts that you might actually start building your own clusters and nodes at the top. I'm getting pretty tired of going in before doing anything and grabbing a, you may know, I do this more often than anything, is grabbing myself a nice range, going into my math tool, grabbing myself a domain. With that, I always grab my expression tool and make my expression tool x minus 1. I mean, this is really a slowdown for productivity. Then I've got to go in and take in my y. I've got to go in and change my variable back to just an x. And that's sitting there waiting to install into here. I may at times then want to put on a pi because I'm doing a rotation. I want to deal in radians, so I'm constantly throwing that through a pi factor. And then my domain, I'm usually, for the pi rotation, typing in a number slider at 0.2.00, and that's always the input into that. And there you've got a simple rotation that now you can take an item, find the list count, and I'm not done. You'd also want to go and get list length off of an item. So you grab an item, you throw it in here, you do a type of manipulation to it, probably a rotate 3D. And so you've got this whole thing that you've also got to find center from volume, if it's a solid or an area. So you're constantly going into here, surface tool, and grabbing a area or grabbing a volume. You're choosing those as centers. Your axis, your angles going here. Your axis can change from X, Y, Z. You may want to cluster something like this. So then you can bring in any geometry you want, put that geometry through the list item, put that into the geometry, find the centroid of that, and it's not going to work right now because I don't really have enough. Why isn't it working? Axis, rotation, finding center of the. Oh, that's because a cylinder, if you remember, and you'll slowly get better at this. And I'm just throwing this at it as the end as a kind of bonus. You definitely got to cap that.